Now let us try to draw the diagram for the ninth question. So what has been given is there is a building and there is a tower. We don't know which of these is taller, relatively taller, we don't know. So the angle of elevation of top of a building from the foot of a tower is 30, and the angle of elevation of top of the tower from the foot of the building is 60. So basically the elevation is more from the bottom of the building. So let me draw a tower and a building, something like this. So imagine this is the tower, and let us imagine this is the building. So as per the question, what has been given is the angle of elevation of top of the building. So basically, let me mark it first. Let us mark the building, sorry, let us mark the tower as AB and the building as CD. So as I told you, we don't know which of these is taller. Let us try to find it out. So this is the floor, and this is the ground. Now, the angle of elevation of top of the building, which is C, from the foot of the tower. This is the foot of the tower. If you look at the diagram, this CD is the building and AB is the tower. So from the foot of the tower means this portion. From that, angle of elevation of top of the building is given as 30 degree. That we are marking it. So we need to understand what is meant by foot of the tower. Foot of the tower means the bottom portion of the tower. Top of the building means C. So basically this is the building. Okay, and this is the tower. Let us try to understand that first. So this is the tower and this is the building. So the top of the building from the foot of the tower, the angle of elevation is 30. Now if you look at the second line, the angle of elevation of top of the tower, to look at the top of the tower from the foot of the building, the foot of the building, it is 60 degrees. So this is the diagram. And if the tower is 50 meter high, they have mentioned the height of the tower. We are supposed to find the height of the building. So this is what we are supposed to find. So this is what is being asked in the question. And we can also replace interchange the positions, like building can be drawn in the left and tower can be drawn in the right. That is also possible, but the angle should be intact. So this is how we draw the diagram for question number 9. Let us see how we can do this. First, I am taking the triangle. So in triangle ABD, I am taking this triangle. So I'm also going to highlight it for you so that you're able to understand it better. I'm highlighting it with blue color. This triangle is what I'm taking. Now within this triangle, so let us concentrate only on this triangle. So within this triangle, we'll be applying tan 60 because that is the angle in this triangle. So what we do is tan 60 degree is equal to the opposite side is 50 meters, which has been very clearly given in the question as height of the tower. And adjacent, let us take it as x. Instead of BD, we can take it as x, or we can have it as BD as well. We know that the value of tan 60 is root 3. Now x goes here, root 3 comes here. We all know this. So now we get x equals 50 divided by root 3. We can either take the conjugate to rationalize the denominator in this step, or we can have it like that and we can do it in the next step also. So I'm having it like this. So we can do it in the final step, the rationalizing. So tan 60, that is because the opposite side to 60 is 50 and the adjacent side is x, and opposite by adjacent is tan, and the value of tan 60 is root 3. So this is what I get the value of x. So x goes here and root 3 comes here. Now I'm going to choose the other triangle also, which means please look at the green color now. I'm going to take this triangle now because that is where we have h, and that's what we need to find out. I'm doing it in the right side of the screen. So in triangle CBD, let us try to understand CBD. So in this triangle, we can clearly see that the angle is 30. So tan 30 opposite will be, why tan? Because we don't require the hypotenuse. We only need the opposite. If you look at the diagram, the side opposite to 30 degrees is h, and that's what we need to find. And the adjacent side to this is x, which has been already found as 50 by root 3. We'll do that, but we know the value of tan 30 degrees 1 by root 3. Now in the next step, h divided by, in the place of x, I'm substituting 50 by root 3. And this is from the previous step, as you all can see here. From that's why from I'm taking this value is equal to 1 by root 3. So now h equals 1 by root 3 times, now 50 by root 3 goes to the right hand side. You get 50 divided by root 3. So now you get h is equal to 50 by 3. So this is the answer. Root 3 into root 3 gets 3. So 50 by 3. When you get fractions like this, you can actually decimalize it. So you'll be getting something like 16.66, which can be approximated to 16.67 meters. So this is the answer for ninth question. So you conclude it as a statement by writing height of the building is 16.67 meters. And you can clearly see that the building is much smaller than the tower, which is 50 meters. Now let us learn how to do the 10th question. So it has been very clearly given that two poles of equal height are standing opposite each other on either side of the road. Now let us imagine this is the road and these are the poles. So let us imagine these are the poles. And they have very clearly given that both the poles are of equal height. So I'm not drawing like one of them is taller or something like that. So I'm drawing as if both the poles are of equal height, which has been very clearly mentioned in the question. So two poles of equal heights, there are two poles, which both of which are of the same height, are standing opposite each other on either side of the road, which means this is the road. Imagine this is how the road is going. I hope you're able to understand. So this is how the road is going. And there are two poles on either side of the road. The road is 80 meter wide, which has been very clearly given in the question. So when they say which is 80 meters wide, they are trying to talk about the road. So let me read the question once. Please observe. Two poles of equal heights are standing opposite each other on either side of the road, which is 80 meters wide. So road is 80 meters wide. From a point between them on the road, let us imagine this is the point. Okay. The angles of elevation of top of the poles are 60 and 30. So the one that is closer is 60 and the one that is far away is 30. So which means that the point is more closer to the first pole than the second pole. Suppose if the angles were 30 and 60, then we would be able to understand that the point of observation is more towards the second pole than the first pole. Let us observe, let us imagine, or let us take note the point of observation as P. Let us take the pole 1 as AB and let us take the pole 2 as CD. So this is all given, and also the angles have been mentioned. From the point of observation, the angle of elevation of the first pole is 60, which means the point is much more close. That's why the person has to raise his head. And also from the second pole it is 30, which means it's far away from the pole. That's why he need not raise his head so much. So we have been asked to find the height of the poles, which has not been given, but we know very well that both the heights are h and h, which means both are equal. So I'm assuming both the heights as h and h. And we are also supposed to find the distance of the point from the poles, which is we are supposed to find this distance as well as this distance. We know the whole width of the road is 80, but what is the distance of the point from the first pole and the second pole? That we don't know. So let us assume this value of BP as x. So some of you might think we'll assume this as y. No, because we know the whole thing is 80 and the remaining will be 80 minus x. So we are assuming BP value as x and the remaining value will be 80 minus x. So this is something that we should know. I hope this is clear. Now let's try to find the answer for this. So very similar to the previous problem. First, I'm choosing this triangle, which I'm shading with brown color, and then I'm going to do it. So now I'm applying tan 60. So when I apply tan 60, I get opposite side, which has been assumed as h, and adjacent, which has been assumed as x. So you get the value as root 3 because that is the value of tan 60. Now in the next step, this becomes h equals root 3 into x. Let us mark this as equation because here at this point we don't know h and we don't know x as well. Next we go for the other triangle, which I'm going to shade it using blue color. So when I consider the blue color triangle, which is tan, just a minute. Yeah, so which is tan 30. It's very clear that the side opposite to 30 degrees is h and the side adjacent is 80 minus x. How we got 80 minus 6 is the whole width of the road is 80, of which we have subtracted the BP's value, which is x. So this is 1 by root 3. We all know this. Let us mark this equation as 1. So now when we cross multiply, this becomes root 3h equals 80 minus x. This is what we get. Root 3 goes to the left side, 80 minus x comes to the right side, and we get root 3h equals 80 minus x. Now, so basically here we are going to substitute 1. So when I substitute condition 1 in this equation, so instead of h, I'm going to introduce root 3x. So there is already root 3, and instead of h, I'm going to introduce root 3x equals 80 minus x. So I'm repeating, in this step, in the place of h, I'm substituting root 3x from condition 1. Now root 3 into root 3 will become 3. I'm doing it here. So root 3 and root 3 will become 3x equals 80 minus x. Now this minus x, when it comes to left side, gets added, becomes 4x. So 4x equals 80, x equals 80 divided by 4. You get x is equal to 20. This is the value of x, which is 20. And we all know if x is 20 and the whole road is 80, the remaining distance will be, so let me write it here. So the remaining distance, okay, that is the distance from the other pole, will be 80 minus x. That is what we have assumed. So now we have got the value of x as 20. So the remaining distance will be 60 meters. So now we are able to understand the point of observation is that 20 meters from the first pole and 60 meters from the second pole. But we need to find one more thing, which is height of the pole. Again, from the first condition, it is very clear that height of the pole is root 3x, which is root 3 into x value is 20. So we conclude by writing the height of the poles, both the poles is 20 root 3 meters. Please be mindful of concluding it with the unit. So this is very important. Both the diagram has been given for question number 11. Let us try to understand how the diagram has been designed. A TV tower, which has been shown in the figure as AB, stands vertically on a bank, which means it's standing upright 90 degrees on a bank of a canal. So which means there is a canal, there is a water body from a point on the other bank directly opposite. So basically the canal is only this much. Whatever I'm showing as blue color with some waves and all that, that is the canal portion, which is BC. Now, from a point on the other bank, so which means they're talking about C, the point C. Okay, so from the point directly opposite the tower. So opposite to the tower, from a point on the other bank directly opposite the tower, the angle of elevation of top of the tower is 60 degrees. Now this is clear. From another point 20 meters, look at the fifth line. From another point 20 meters away from this point, which is here. 20 meters away from this point, in the sense away from the first point of observation. Then also they have given one more thing. When we say 20 meters away from this point, it can be in any direction. Backwards, front, left, right. To clarify that they have given away from this point on the line joining this point to the foot of the tower. The line joining this point to the foot of the tower is BC. This is the line. So on the same line, 20 meters backwards, that is what they have given. Otherwise, we may get a confusion. So because in the fifth line, they have just given 20 meters away from this point, which may even be this way, or even front side. We don't know. For that, to clarify that only, in the question, they have given extra information, which is, where is the 20 meter away? It is on the line joining this point to the foot of the tower. When we join this point to the foot of the tower, on the very same line, when you extend backwards, that is where the second point of observation is. And from that point, the angle of elevation is 30 degrees. So now find the height of the tower. We are supposed to find the height of the tower. Let us assume the height of the tower as h. And also width of the canal. Let us assume the width of the canal as x. We know that the distance away is 20 meters. So we are with all these values, and let's get started. So now let's solve this. So very similar to the previous questions. Again, we are going to target this triangle, which is ACB. We can also choose to start from the outer triangle as well. So I'm planning to do this. So basically tan 60, this is what I'm applying. So when so I'm going to choose this triangle, which is in triangle ABC. So when you try to concentrate in this triangle ABC, it's very obvious and clear that tan 60 is what we are going to apply, which is opposite is H and adjacent is X, which is root 3. This is very similar to the previous question. So you get H equals root 3X. So this is something that we need to know. And we name this as condition 1. Now, let us try to do the other part, which is the larger triangle, which I would like to shade it using the blue color, this one. So let us try to target in the larger triangle. So now what happens is tan 30. So when I use tan 30, the opposite is H. And so the adjacent side will be 20 plus X, because that is the complete adjacent side, as you all can see. So for 30 degree, this is the complete adjacent side, which is 20 plus X. It's not only 20, it's the whole thing. So 20 plus X, that's what we have assumed it as. And now, where the value of tan 30, we all know it is 1 by root 3. And now when you cross multiply, this becomes H root 3 equals 20 plus X. Okay. Now, in the place of H, I can substitute root 3X from condition 1. And there is one more root 3 here, as you all can see, 20 plus X. So I'm using this condition 1 here. In the place of X, I'm substituting root 3X. Now I get this as 3X equals 20 plus X. And X comes to the left side, gets subtracted. You get 2X equals 20, and you get X is equal to 10. So this is the value of X that we are getting. But we are supposed to find the height of the cover. So when we substitute this value of X in the first condition, so let me write it as substituting in condition 1. So you get H equals 10 root 3 meters. So when we substitute the value of X in the condition 1, we get the value of height of the cover is 10 root 3 meters. So this is how you do the 11th question. Now let's see how to draw the diagram for the 12th question. From a top of a 7-meter high building. So they have very clearly given that there is a building. Let me draw it like this, which is 7 meters. So this is the building, and I'm naming the building as A. And I'm also marking the ground like this. Now the question goes like this. From the top of a 7-meter high building, the angle of elevation of top of a cable tower is 60, and the angle of depression of its foot is 45. So this actually means that the point of observation is A. And when you see a cable tower from A, so you're standing at A, on top of the building you're standing, and from there, if you look at the top of a cable tower, it is elevation, but the bottom of the cable tower is depression, which means that the cable tower that is opposite to you is actually taller than the building that you're standing on. So it is something like this. So this is something that we need to know. So this is something that's very important. So let's try to understand this. So this is the cable tower, and I'm representing the cable tower as CD. I repeat, how do I know that the cable tower is taller than the building on which I'm standing? Because it has been very clearly given that the point of observation is A, and from A, the top of the cable tower is at elevation and the bottom is at depression. If this tower was smaller, then the top will also be depression, the bottom will also be depression. So this is something that we need to know. So I'm repeating, AB is the building whose height is 7 meters, and CD is the cable tower. So I can even write it over here. So this is the building and this is the tower. This is the cable tower. So we are also drawing the horizontal from A, because the person is standing at A. So we need to know the horizontal from A as well. Now, it has been very clearly given that the angle of elevation of top of the cable tower is C. So that angle is 60 degrees. That has been clearly given in the question, like this. And also the angle of depression of its foot. So from the same point of observation, the angle of depression of its foot is 45 degrees. So this is also given in the question. Nothing else, and we are supposed to find the height of the tower. So let us imagine the height of the tower could be the whole thing. So this is what we are supposed to find from the question. Let us assume this point as E. And first of all, one thing that we have to understand is, if this is 7, then this is also 7. Because basically it is a rectangle and it is the opposite side. You can see very clearly this will also be 7. You need not write any steps for that, but this will become 7. I mean, ED will become 7. So if ED is 7, then the remaining CE will be H minus 7. This is because we have assumed the whole thing as H. And this is 7. So when you subtract 7 from H, you get H minus 7, which is CE. I repeat, we have assumed the whole height of the tower as H, then that's what we're supposed to find in the question. And since this is the building's height is 7, you can carry it over here, and this will also be 7. So when the whole height is H, and when you subtract 7, the remaining height CE will be H minus 7. Now we are going to apply, maybe we can take this triangle first. So we are choosing the triangle where there is an angle. Okay, or we can do it in other way also. Some of you may even choose this triangle. So you'll be wondering where the angle is. This 45 can be brought here. This will also be 45 because they are alternate interior angles. So we can do like that as well. I repeat, we can also take this triangle. You may be wondering there is no angle here, but this angle is also 45 because this angle and this angle are alternate interior angles. Actually, we can bring it over here and we can do it for this triangle. But I'm choosing the other option. I'm taking this triangle and I'm going to apply the concept of trigonometry. So now when I apply, so I'm choosing triangle AED. I hope you're all able to see. And in AED, I'm applying tan 45. So when I say tan 45, the opposite to 45 degree is ED, which is 7. And the adjacent to 45 is AE, and we don't know the value of this. I'll have it as AE itself. And you know the value of tan 45 is 1. Now AE goes to the right side, it becomes AE, and therefore you get AE equals 7 meters. So this is the value of AE. So I'm updating it here. This will be 7 meters. That's what we have got from the first step. Now what we are going to do is we are going to do the trigonometry for the other triangle, which is the upper triangle, which is ACE, the blue color one. So here I'm choosing in triangle AEC or ACE, whatever. So now when we apply tan 60, you get opposite is H minus 7. I explained it initially, and also adjacent was unknown, but now we know the value as 7 after updation from the step 1, and we know tan 60 value is √3. So the next step you get H minus 7 is equal to 7 √3, and you get H equals 7 √3 plus 7. Minus 7 goes to the right side, becomes plus 7. So this 7 can be taken as common out. You get √3 plus 1 meters. So this common out step is not so important, but it's better you do it for simplicity reasons. So you take the 7 as common out, and wherever you have 7, you get 1 in the place. This is the height of the tower.